Right. Good afternoon, and thank you for your patience there. I am delighted to welcome you to today's Royal Academy of Engineering CAFÉ event. So this is an opportunity to bring together Academy awardees to discuss topics of interest. I am Richard Dawson. I am a professor in the School of Engineering at Newcastle University. And my own background is in civil engineering and looking at adaptation of our infrastructure to climate change impacts. I'm delighted to be joined today by an excellent panel. We have Dr. Anna Mijic from the Imperial College London, where she is the director of the Centre for Systems Engineering and Innovation, and Dr. Raghav Pant, who is a researcher at the Environmental Change Institute in the University of Oxford and has been a key researcher in the Infrastructure Transitions Research Consortium. Before we kick off our discussion today, I'd like to give both Anna and Raghav a quick opportunity to introduce themselves and a little bit more about their background. So perhaps, Anna, could I ask you to kick off, please?
Of course, thanks, Richard. My name is Anna Mijic, so I am a reader in Water Systems Integration at Imperial College, which is, I guess, telling about my background. So my background is in civil engineering, but I'm specifically interested in most of 90% of my work is on water systems and water infrastructure. And I am particularly interested in long-term planning under climate and other changes that are happening within the environment. I am interested in adaptation and how we can address and develop options to manage the system in the long-term future.
Thanks, Anna. Over to you, Raghav.
Hello, and thank you very much for this opportunity to the Royal Academy. My name is Raghav Pant. I'm a senior research associate at the Environmental Change Institute in the School of Geography at the University of Oxford. I've been working here for more than 11 years now. Before that, I did my PhD on graduate studies in the United States, and originally I'm from India. I have also a civil engineering background, and I primarily look at developing detailed network models of connected infrastructures. So my main thing is looking at large-scale systems and how these systems are impacted by climate risks and where we can pinpoint vulnerability and risk hotspots, and then from there how we can plan climate adaptation of infrastructures and look at investments at the national scale. So very excited to be here and participate in the discussion and make my contributions. Thank you very much.
Thank you both for that. So before we start with a few kind of questions and discussions, I'd just like to draw everybody's attention to the Q&A button at the bottom of your Zoom screen. So if you do have any questions you'd like the panel to explore later in the discussion, then please do fill in those questions. If you see someone has asked the same as you, then please feel free to click like and vote it upwards, as it were, to draw it closer to the top for our attention. And we can come to those in a moment. But perhaps before we think about what we mean by climate resilient infrastructure, I'm wondering, Raghav, perhaps if I come to you first, you could give us a bit of a sense of what are the kind of current risks to infrastructure from climate change, and how might these kind of evolve and develop in the years ahead?
Thanks, Richard. So first of all, infrastructures, as we know, are these, what we think of infrastructures as these large-scale systems that are spread over enormous geographies, spanning not just like your local scale, but regional, national, and continental scales. So they are exposed to, I would say like everything, because infrastructures are kind of built in areas which are coastal areas where sea level rise and is affecting them. Then they are also kind of, we see floods all over the place across all sorts of infrastructures. Of course, extreme winds, precipitation, and all the kind of climate well-known factors of extreme temperature, they all affect infrastructure. these infrastructures, which we generally kind of refer to, for example, large-scale energy systems or transport systems or ICT or water systems, over the last, I mean, several decades, and especially we've been seeing them in more recent history, they are being increasingly exposed to these extreme weather impacts that are, many of them are being attributed to climate change as more and more evidence is being collected. At the University of Oxford, in the department where I work, there is a group which looks at this idea of climate attribution, which is all about attributing the recent kind of extreme hazard events, extreme events to climate change, where the link still is weak. We say climate change is more about looking at the long-term trends, and extreme hazard events generally, we say that the link between them and climate change needs to be further kind of defined. But now we're trying to, with more and more evidence, that link is becoming more and more evident. So in the last 5 years, I mean, while we have seen big kind of disaster events, and more these disaster events are being the impacts, the dollar values of these disaster impacts is also increasing, because there's a lot of built infrastructure also, and it's being developed all over the world, all over the time, in hazard and disaster prone areas. So I mean, in terms of like concrete figures and numbers, I mean, if you look at recent events, all of them, generally many of them, like tropical cyclones, for example, in the United States or the Caribbean islands, and in the UK, the winter flood events in the recent year, they all have kind of touched up to billions of pounds of damages and losses. And so yeah, these things are all increasing, and the evidence as we are collecting over the last 5 years suggests that infrastructures are increasingly exposed to climate risks. So I mean, that's all I would say at this time.
No, fantastic. Thank you very much. And I mean, Anna, you highlighted your particular experience in the water sector. Would you mind just giving us a quick summary there of some of the big challenges?
Yeah, so I think from the water systems, the two most discussed are, of course, the extreme weather events, but on both sides. So we can have extreme, and we have the increased frequency of the high intensity rainfall. So we have huge issues with flood events, and on the other hand, we have longer dry periods, which then questions the resilience from the perspective of drought and the water supply side. But the other aspect that I would really like to mention, which comes to the complexity of the systems, is also the interlinked issue of the water quality, because the climate resilience, I think, is very closely linked with the environmental resilience as well. Raghav mentioned the complexity of the climate systems and infrastructure systems that we are operating in. So it's a very complex problem, and lots of things interlink and work together, which makes the problem very challenging.
Thanks. Yeah, I mean, perhaps we could come back to this theme of interconnections and interlinkages in a moment. But the kind of the focus of this CAFÉ discussion is around resilience. And we know that when infrastructure fails or is damaged, so not completely failed, but you know, that can lead to environmental, social, or economic impacts. So I think the idea of resilience is understood broadly to, you know, better cope with these sorts of failures and impacts. But how can we prepare for that failure? What do we mean by resilience, and how can we start to actually tackle that? Raghav, do you mind if I come to you first?
Yes, sure. Thank you very much. So in the most simplistic term, resilience is the capacity to absorb a shock and then recover in some timely manner, and recover to, I mean, the bare minimum is recovered to the original state of pre-disaster functioning. But of course, there's a desirable that systems sometimes might actually improve after a disaster to provide better functionality if resilience is built in a bit of an a bit of improving a system. So yeah, I mean, when it comes to kind of understanding resilience of infrastructure systems, yeah, I mean, the kind of things, I mean, as and also talked about the complexity and the interdependencies of infrastructure, just not thinking about like one infrastructure as a by itself, as a siloed system, but its interactions with other infrastructures as well, which can determine its ability to be affected by impacts and withstand shocks. So when we think of resilience, it's not about kind of your physical concrete assets in space, but also the connections between assets and the functionality of the system as a whole. What kind of benefit does improving resilience provide, just not to my immediate local asset, but to the whole system as a whole? And yeah, I mean, I'll stop here, and then as we discuss, we can add more points.
Thanks, and I mean, Anna, you've done a lot of work on thinking about the resilience at that whole system scale. Have you got any sort of further thoughts to add on that? How do we even measure or identify what to measure in terms of defining system resilience?
Yeah. So for me, this is the kind of fundamental question, in a sense. What do we want to achieve with the climate resilient infrastructure? So if the resilience is that systems should recover and function at a desired performance, then I think the question is, what is a desired performance? Is it normally we use the threshold values, but the system is very dynamic. So how we look at the thresholds which define our resilience in that dynamic way. And the other aspect is what we mentioned around the components of the system. So what do you want to, which component of the system you want to be resilient? Do you want your water supply to be resilient? Do you want your wastewater infrastructure to be resilient, your flood protection, or all together to achieve the outcomes? And I think the notion of the outcomes is here really important. What do we want to achieve with our infrastructure? And then how resilience could be one of the indicators that we can use to inform our management and planning decisions.
Great, thank you. So it's a complicated problem. Now I'm going to reflect on my journey back from Leeds last night, and what should have been about a 90-minute train journey between Leeds and Newcastle was disrupted in a number of ways. So there were some high winds that blew down some overhead train lines, apparently also blew a fence onto the railway track in front of our train. There was some localized flooding, which meant that train drivers couldn't get to the railway station to drive our train to York. And there was a landslide in one of the railway embankments. It was quite a lengthy journey in the end. And these things all seem to happen at once and around all driven by, I suppose, a particular event or storm that created a number of different hazards. And as engineers, we're often used to sort of tackling one of these problems at a time. So how do we actually ensure or start to develop infrastructure systems that are resilient to multiple events or sequences of events? And perhaps, Anna, if I come to you first, and then maybe I'd like to explore with Raghav the kind of cascading failures and interdependencies between physical systems, but perhaps come to you around the sort of the compound events and multiple things together.
Yeah, I mean, the easiest way, at least for me, because so my work is on modeling. So we model the systems and we use the models to assess the performance of the system and then inform the resilience metric. I think what is maybe the key there is to think about all the possible stresses that can change in the system. So then, and there are two ways then to think about that. So we either then run them individually, or we try to get to these compound events and find the worst case scenarios. And that really comes to either the kind of scenario assessment, or if we want to go into the future planning, looking at how the current scenarios also might develop in the future. But I think that the notion of the possibility space, in a sense, really stressing your system with the ranges of possible changes in the drivers will give you maybe the area where we can define the kind of pass failure modes of the system performance. And I think that will really give us, I guess, pretty good overview of what might happen I guess what you're talking about then, Richard, is, what do you do if that happens, which is another story. But at least with the kind of what if scenarios and stress testing the system with the models, we can know the combination of the events that will bring our system to the failure performance.
Fantastic, thank you. And Raghav, you've done a lot of work looking at how our physical infrastructure networks interact, and failure in one can kind of lead to a disruption elsewhere. Would you perhaps, reflecting on that, how do we use that knowledge and understanding to help us build more resilient systems?
Yeah, thanks. First of all, I'll say, Richard, you had a very adventurous journey. So yeah, I mean, and you faced all sorts of multi-hazards and cascading failures all at once. So we kind of need that kind of evidence as well. Unfortunately, you were caught in it. So when it comes to kind of cascading failures, yeah, this is kind of work that we do here in Oxford a lot, which is about thinking of the railway as an example, and the network requires a lot of kind of interdependence with other infrastructures. For example, energy for the electrification of the railway lines and the traction systems, telecommunications systems, water systems, and whatnot. And we see this definitely kind of how these interdependencies are very desirable in the creation of the infrastructure or the engineering design, because of course we want kind of they are designed to enable smooth functionality. And as we are moving more and more into more smart systems, this is going to be this interdependency, interlinkages between systems is going to be even more and more. We'll see it more and more of it. But then what is the kind of drawback of this is what we see in terms of during a disaster event, that these interdependencies create cascading effects where kind of one infrastructure failure might just create further knock-on effects on other infrastructures because they're so interlinked and interdependent. And in order to kind of understand what might happen to any given infrastructure, that's why we have to kind of look at least some level of its interdependence that it shares with other infrastructures. And using the railways as an example, I mean, a few years ago, I was doing some work for the high-speed 2 rail project, which, well, I'm not going to talk about that project here, but there was a bit of a study in terms of like trying to map interdependencies of the high-speed 2 railway system with respect to other infrastructure network, and especially with respect to existing infrastructures which have been built. We don't know much about them because they were built in the Victorian era, and their design standards and their kind of their ability to withstand climate shocks, little bit of is known about that, to be honest. And so kind of but having an understanding of mapping any new infrastructure that is built to improved and enhanced design standards to withstand future climate impacts. We also need to understand how that you might spend all your money in kind of building a new shiny piece of infrastructure, but then its connectivity and dependent on the old infrastructure might be something that might actually still cause failures. And we see a lot of that. So that is something that we should really focus on, definitely. And this interdependence and cascading effects is really important, because it does. I mean, you're trained from Leeds to Newcastle. I mean, there must be some individual singular points of failure, but then it knocked on a whole route, which is that's where the interdependence cascading comes into play.
Yes, well, fortunately for me last night, I did at least make it home. So it was just a performance issue rather than a total failure. But thank you very much for whoever has put a question in the chat. Or not in the chat, in the Q&A box rather. We'll come to that in a moment. But please, could I draw attention to everyone else who's joined us a couple of minutes late, that if you'd like to ask a question of our panelists, to put it in the Q&A box, which is at the bottom of your Zoom screen. Anna, I think there, just from Raghav's response, that we were kind of getting into the field of thinking about some of the lessons learned or the challenges in terms of what works well, what doesn't work so well in terms of actually achieving some form of resilience in our infrastructure system. Have you got any thing to add to that? Any experience of yours about what's a good way of delivering resilience?
Well, I think what is maybe interesting to mention here is and I think something that really interests me, I think we'll maybe come to, what are the still kind of maybe even research challenges in the assessing the climate resilience or designing climate resilience infrastructure, is the way, at least for the water systems, how the thinking about the resilience is done, or how we calculate what are the impacts of the extremes. Because if we're talking about the resilience, we're talking about the extreme events that change the performance of the system. And for the extreme floods and droughts, we very often talk about the 1 in n years flood or 1 in n years drought, which is how it was traditionally done based on statistical analysis of the extremes. But there is an issue, and then, okay, of course, we use those extreme flows, high or low flows, to design our infrastructure. So either the flood protection in the case of flooding, or some form of water supply buffer reservoirs, for example, and so on, which of course brings the resilience very high up. So, and if you do traditional calculations of the resilience, your water supply and your flood systems will be really resilient, because they were designed with the notion that 1 in X years event shouldn't affect the system. Of course, now the climate is changing, so the frequency of the events is changing. So this is the first thing. But the second thing, really from the perspective of the management, especially adaptive management, that is slightly challenging. I mean, it's really tricky, because what we can do very often is to over-design the system. So we are making an assumption, and we have a certain risk that we have been working with. But on the day-to-day operational basis, that additional capacity gets utilized very, very rarely. So I guess for me, then the question is, can we do better than that? And I think it opens the question around adaptive planning and flexibility in the infrastructure design, which I find very, very interesting. So can we design the infrastructure that can change the capacity in a relatively short amount of time when we know the challenge is coming? Or can we utilize the operational side of the infrastructure? We have lots of data now. The systems are digitized, very well connected. Could we use the change of the operational rules and maximize the change in the operations to manage our resilience? So I think these aspects between the kind of traditional, this is the risk, build protection, versus a much more agile thinking and maybe increasing the level of risk, but generally, I think decreasing the costs and giving that flexibility to adapt for whatever the future might be is really interesting to me.
Thank you. So are there any examples of where this has worked well, do you think?
Well, I mean, the adaptive planning in water systems is still a really big topic. I mean, one example of the project that has adapted that thinking is the Thames barrier. So the way of thinking about the kind of long-term scenarios, and then finding the options on how to increase the capacity of the Thames barrier to adapt to different possible different changes in scenarios. I think it's a really good example. I think the challenge in adaptive planning is coming back to the complexity. So if you look at a single infrastructure system such as Thames barrier, you have single key source of the risk, which is the sea level rise, and then you have basically one risk, one infrastructure system. If you say move into the cities, then it becomes much more complicated. Of course, we have the increased risk of, say, high precipitation, but then your capacity or the set of interventions that you can implement is really multiple. So you can either add your capacity in your network system, you can add capacity with I think the question will come back to that around the nature-based solutions. You can reduce you can do the rainwater harvesting, so then it affects the system. So, and then the question is, how do you use all these building blocks to maintain the overall resilience of your system? So I think there is I think we have the elements. I don't think we have put them together yet so that we really know how to do adaptive planning of complex systems.
No, thanks. Very interesting. Raghav, what about you? From your experience, have you seen approaches that have been either very useful or maybe haven't worked in terms of a good investment of time, money, resources?
So yeah, I mean, having done some studies in different countries, I mean, one of the questions definitely that we face a lot is how to essentially plan for climate adaptation, because the question of are we going to face climate risks is very clear to most stakeholders in most countries, but they're like, they always come back to us and like they don't know what to do with that, in the sense that they don't, first of all, know how to highlight their vulnerabilities and hotspots, and then also how to consider how much to invest in what kind of climate adaptation options. So based on kind of my experience, we've seen, for example, I did some studies in Argentina, in Vietnam, and there they had there's some key new road developments that they had done, which got flooded within 1 year or 2 years of building, and which kind of building these new projects, and which actually resulted in some communities being cut off during the flood seasons. So the question generally is like, then how exactly could they have planned better for that? And one of the things kind of we realize is that as Anna was saying, this adaptive nature of kind of understanding your future climate scenarios, which as more evidence is being collected, because lots of these predictions of future climate change are also kind of evolving as we are collecting more and more data, and also what will be the extremes which are being predicted. The modeling itself is improving. So many times you find that the assessment that has been done in building new infrastructure didn't take into account a more extreme instance of say a sea level rise or more extreme rainfall than what data was collected, because the model itself didn't capture those extremities. So we see those kind of instances where kind of those kind of projects don't really perform. Successes, yeah, I mean, they're difficult to define, and Anna rightly pointed out the Thames Barrier as a success project. But yeah, increasingly, I mean, I know that, I mean, in Netherlands, of course, kind of there's a lot of infrastructure which has been built to be protected against 1 in 10,000 flood events, but they are also kind of evaluating their current kind of assessments of future climate scenarios. So yeah, this is always kind of, I think we cannot say something is a success, because we always have to kind of keep kind of assessing it after a few years, I guess, again and again, and adapt it and assess our own adaptation assessment.
Thanks. So I'm going to move over to the chat or the Q&A questions, and as Anna pointed out, there's someone has asked around whether natural or nature-based infrastructure systems are more resilient than traditional systems. I know, Anna, you've done some work on green infrastructure in urban areas. Perhaps you'd like to kind of kick off on this one.
Yes. So I think I guess the question is a bit, so are the natural systems more resilient than traditional? So and I would kind of rephrase that in a sense, depending on how you define your resilience and how you calculate your resilience. So the typical example, and we've done lots of work on the nature-based solution in cities in the context of urban flooding. And if you calculate and if you compare your pipe system with your nature-based solutions one-on-one with the same thinking around design storms and the return period, of course they won't, because that concept is you design your pipes for a certain, say, 1 in 30 years event, and of course your nature-based solutions cannot manage the same amount of water. So, but I think it's very unfair comparison, and something we have been working on, and I think it comes to the integrated water management perspective, is how gray and natural systems work together, and they all have a certain function to have in the system, which is the same also as kind of any kind of operational changes and so on. So green infrastructure has its function for the low intensity events, so it cannot manage the high peaks, but it can really slow down and reduce the flow, but it has all the other, you know, benefits around the ecosystem services and so on. Well, then, you know, when the level of risk increases, then of course our infrastructure, gray infrastructure, takes that function. But the combination of the two, I think, is really interesting, and for me, the question about nature-based solutions is not only, what is their performance in the numbers, it's their overall role in an urban system, from the water management, because they also have the benefits for water quality. You can also design the reuse systems underneath the green infrastructure and so on. So thinking about the multifunctionality and thinking about how existing gray and natural systems work together, and when one is dominant, when other takes on the function, I think is for me the right way of thinking about the role of nature-based solutions.
Thanks. And I'm going to kind of follow that up, because you touched upon the issue of kind of multifunctionality and providing different benefits and so on, which contribute, with another question that was posted in the Q&A, which starts off by asking around measures being taken to ensure the resilience. But I think what's interesting from the point you raised around how we bring nature-based and grey infrastructure together, is that to provide that sort of more integrated approach, are our current governance models, business models fit for purpose to take full advantage of these systems and ensure the resilience of our sort of urban spaces and water systems?
Well, I mean, I can maybe start, and maybe if Raghav wants to take over. I think the question around the human element, I think what you're mentioning, Richard, is the kind of people in the system, which is also really important, because fundamentally we design the infrastructure, we operate the infrastructure, our demand defines the performance of the infrastructure. So operational management and governance aspect is really, really important. And I think anything, we talked a lot about the modeling, both Raghav and I, and because this is probably the most core of the work we do. But then what happens with the results from the models is a completely different level of work, engagement, research, and so on. So I think it's really important element. So from the quantitative side, I see all our work and value in providing the evidence, but then on the implementation side is what is then done with that evidence. And I definitely think, at least from the water systems perspective, our ways of operation of the infrastructure really doesn't allow for any interlinked solution. So we did the work a couple of years ago to look at if we would reduce the obstructions during high rainfall events, what would be the implications for the discharges and downstream water quality? And with the small operational change, there was a significant improvement of the downstream water quality, because you're leaving more water in the system. The system is hydrologically connected. But then when we discussed this with the water company, they absolutely had no internal capacity to even think about the implementation of such a measure, because their water supply and wastewater systems, all the physically connected operationally, are quite disconnected. And I think this will be a huge problem, even if we can model measures and solutions from the integrated perspective, how the implementation will be possible to happen.
Thanks. Raghav, have you got anything to follow up with on that?
Yeah, if I may add, I'm gonna agree with everything that Anna said. And one of the things, Richard, you raised about the business models of kind of nature-based solutions. And yeah, this is a difficult one. And as Anna said, I mean, comparing nature-based solutions with grey infrastructures and comparing them in the same way generally kind of actually ends up making a worse case for nature-based solutions. And people are generally kind of then saying like, well, then let's just invest in the grey infrastructure. And maybe kind of thinking of how they both complement each other. There's a gray-green hybrid. And I did a project recently in Jamaica where there was a discussion in terms of like enhancing mangroves and coral reefs as in order to reduce kind of the sea level, the storm surges and sea level rise. But then the enhancement requires kind of planting and improving existing mangrove cover, and which would require some time to see how the benefits would be realized, because the mangroves will take years to grow. And whereas kind of the floods or the tropical cyclones might just happen next year or this year. So it was always kind of a question of, so then the stakeholders would, their fallback is like, oh, let's just build like a flood protection barrier because we can see the immediate effects of that. But then that misses that long-term benefits and co-benefits also of nature-based solutions, because if you enhance mangroves and coral reefs, you get so many other co-benefits that we don't really think about, and we don't even quantify them in terms of monetary terms in the cost benefit or whatever return of investment that we are doing. So yeah, there's a need to actually think about how we can kind of have a better quantification of the benefits and the co-benefits, and not just in flood resilience, but other kind of benefits that nature-based solutions provide, and so that a comparable kind of business case for them can be made.
Thanks, and I think that sort of touches upon a question here around the role of members of the public in informing and engaging in some of these questions. We've kind of heard that you know, there's a tendency for people to naturally fall back on a you know, an approach they feel comfortable with, they've seen before, they know it works elsewhere. But yet, you know, individual members of the public are taxpayers. They have a stake in these decisions, and how can they, could they, should they be involved in informing investments in resilience? Would either of you two like to volunteer to start that one?
I can tell Richard. I mean, we are just finishing a big project. It's called Camellia. And one of the aspects in that project was community engagement. So we have done a lot of community engagement around the urban water management. And I think there are two aspects which are really interesting. I think the one is that the knowledge that exists in the communities, and also their capacity to be involved and provide data through something like citizen science, is really important, because especially if the solution will be something around either the behavioral change or implementation of nature-based solutions, so something that affects them directly. They not and I think the second aspect which I wanted to mention, which was really interesting to me, is that contrary to my opinion that everyone will be really excited about the nature-based solutions, actually that wasn't the case. So there was discussion around the implementation of wetlands in one part of a city, and then the community was really against it, because they use the park where the wetland should be built. They use the park for their kids to play, for their to walk the dogs and so on. And they really didn't want to see it, even if the evidence has shown if you do that, your flood risk will reduce and so on. And their thinking was, no, I mean, just get the water company to sort out the runoff. You know, we are fine. So I think there are two sides of that engagement, but I think in any case, there are lots of benefits of doing that, again, from the information side, but then particularly around the acceptance of the solutions that will directly affect the local communities.
Thanks. I mean, Raghav, anything from yourself on that?
I mean, this might be a bit above my pay grade, to be honest. And Richard, you can probably talk about that yourself in your role in the adaptation subcommittee and the other things you've done in the Committee of Climate Change. So, I mean, from my perspective, yeah, what we try to do most of the time when we work in projects which involves important stakeholders in the UK, we try to kind of stress the idea of having kind of more community kind of interaction and user feedback as well, and creating kind of events and inviting people who are not just your big infrastructure operators and providers and regulators, but rather kind of also having people from the general public. So yeah, I mean, that's all I'll say about that at present.
Yeah, no, and thanks for drawing me in there. I mean, there are some direct mechanisms. So the Environment Agency do have local and regional committees in which they do appoint members of the public to be part of that committee for a few years and to feed into decision-making processes. Water companies usually have a kind of an engagement and an outreach programs where people can also get involved. It's less clear how easy it is for those conversations to feed through to decisions in comparison to, say, a formalized committee structure that the Environment Agency have. So there are some mechanisms that do exist, but I think it's fair to say that perhaps more is required there to really engage people and I suppose motivate and encourage them to feel like they have a voice in driving change, especially to the way things are done. What we have often seen is in areas that have experienced serious flooding, their local flood fora are much more engaged, involved, and vocal in challenging decisions and investments and so on that are taking place. I think one example or another mechanism that is used is actually on the coast. So in the coastline, we see shoreline management plans, which are very good at bringing together a lot of different stakeholders, not just the Environment Agency and local authority, but a much wider set of interested parties. I think they still sometimes struggle to bring in communities to really engage in that, but it's probably a better overall process for trying to bring and make sure everybody has a say. So I think more models like that we might expect to see in the future to really engage people. So I was going to ask a question around what advice we might give to engineers thinking about factoring climate change into the design of infrastructure. We touched upon some of that, and there's a question in the chat, Anna, that directly speaks to a point you started off with, but I know you've both sort of thought about this challenge of adaptation. And recognizing that in the Thames, the sort of key hazard is rising sea level. But where should we look within a kind of a dense, tightly packed urban space or another kind of complex infrastructure networks if we're trying to deliver a more agile or more flexible and adaptive approach? How do we start? Where are the sort of methods to help us with this?
I mean, I can start. I mean, I think maybe we should bring the focus back. So we're talking about the climate resilient infrastructure, and we talk about the climate resilient infrastructure. Of course, then the key information for us: what is the climate change? What are the impacts of climate change, and how we deal with the uncertainty? Because if we want to do long-term planning, we need to project. So, you know, and as we go longer in the future, the uncertainty increases. So this is purely from the climate change perspective. Of course, if we then have the climate as an input in our system or input in our model, then climate will affect different parts of the system. So this is really now where we can think a bit about what is the system we want to analyze and which elements of that system the climate change is impacting, and then how these impacts interact within the system. So this is where this complexity really, comes in place. The other thing, which is maybe not directly linked with the climate resilience, but it's generally linked with the resilience of the systems, is what if other things change alongside the climate? Because we mentioned that at the very beginning, the infrastructure systems are very dynamic. So, so they change in the way of what is the infrastructure? Are we adding on, taking down some infrastructure? How we operate, especially on the development side. So from the water systems, any change in urban development will completely change the physical system. So that's why I mentioned these calculations, even kind of, 1 in n year storm is based on the system which it was when the data were collected. So I think going forward, what I would maybe recommend is to think about what the system is and how the system interacts, maybe a bit around the sensitivity of that system to the inputs, and then really thinking about the data that's used to predict the behavior of the system. We have a much better climate projections than we had 10 years ago. We have a continuous climate projections. We have ensemble projections. Of course, it goes into deep uncertainty and so on. And I really believe we haven't really, even from the research side, addressed the adaptive aspect. But we can predict and we can stress test the system much more accurately than we could in the past. And I think we should be using that much more to understand our system and then think a bit about what exactly we want to achieve with the resilient infrastructure.
Thanks very much, Anna. We are coming close to the end of our time, so perhaps I'd like to give either Raghav or Anna a chance to answer Laura's question around the role of government in helping to improve infrastructure resilience. Who is ultimately kind of, I suppose, at the heart of this question, who is and should be responsible for actually ensuring that resilience? Raghav, are you happy to kick this one off, perhaps?
Yeah. The government definitely has a role in ensuring the resilience of infrastructure, and especially when we talk about very large failures, which private insurers or private infrastructure operators, they cannot really cover. When we talk about those very rare events, those high low probability, high impact, high consequence events, that is where kind of the government definitely has a role in terms of making sure that infrastructure resilience is to a certain extent covered. And when we talk about the national infrastructure perspective, because we are talking here about also the role of infrastructures as every infrastructure asset does have a role beyond where it is locally concentrated, because infrastructures are networked and interconnected systems, and this is where the idea of kind of the resilience of the infrastructure is for the benefit of only that infrastructure located in that area is kind of something that is not true. It has a much kind of wider systemic impact, and that's why the resilience of infrastructure, I guess, apart from the government, it is also the kind of the stakeholders who are kind of interested in the fact that the infrastructure provision has to be secure, not just now but into the future. So if we are building for example, a energy power plant, then there's a lot of kind of other infrastructures that depend on that. So to understand how this will affect other infrastructures, so then who should kind of then who will be affected by this and who should then invest in their resilience has to be thought in terms of this, not just in terms of the physicality of the infrastructure and its mapping, but also all the stakeholders who might be, all the companies and all the agencies and the governments who might be affected by this infrastructure as well. So it's a collective kind of investment in resilience, I would say.
Thanks. So we're coming to the last couple of minutes. I'm just going to ask Anna and Raghav if you could both in about less than a minute, ideally, just perhaps summarize what do you think the next priorities are, and the most important thing to do, whether that is around research, policy, or action of some sort. Just some final reflections. Anna, could I come to you first, if that's okay?
Yeah, sure. I think that there are basically three things that I, at least from my perspective, I think one is on the quantification. I think we talked a lot about the complexity, interdependencies, and so on. I think from the modeling side, I think it's still really what we don't do well is, or we don't know what is the exact level of complexity of the modeling that can capture these interdependencies, but in physically explicit way. Why I say in the physically explicit way? Because then we can look at the intervention. So ideally, our models represent the physical complexity, operational complexity, but be able to link so many things. And that trade-off between the scope and the representation, I think it's still a bit of a challenge. I think the second one, and I think it comes to the question in the chat about the probable versus plausible scenarios and the policy. I think definitely we should be going towards policy that promotes adaptive planning. Of course, that will depend on the flexibility in our infrastructure systems, how quickly we can change the operation or add the capacity in the system. But I think it's a really interesting point. And I think that my last one is around the kind of issues around the governance and so on. We are doing work on what is called the system actor network, where you can link the stakeholders to different elements in the system, and then you can look if there is a link between the stakeholders. Does it exist if the system is either physically or operationally connected? And there is a lot of disconnect. So I think linking the physical systems with the social systems and governance is my third takeaway message.
Wow, thank you. Raghav.
Yeah, I mean, I agree with everything that Anna said, and she covered most of it. I would just add, I mean, there's a need for improving data openness when it comes to kind of solving all these problems, because that's one of the biggest gaps. And data just doesn't mean simply kind of data on locations of assets, but there's much more kind of, as Anna said, thinking about even stakeholder mapping and like having that information also open. Who's kind of involved and invested in different infrastructures, and how are these kind of different stakeholders also kind of interacting with each other, and making that data and that information kind of open. All three of us are involved with this new Daphne initiative, which is kind of trying to do that. So the involvement of more and more people within that initiative is very, very useful, because that then creates kind of, first of all, exposure of everybody to some kind of database of knowledge that can be kind of used for individual projects, and where you can also then contribute back. And then in addition to that openness of the data, also the openness of models and tools that kind of could be useful to help work with these kind of systemic problems and solve them, like climate models. I mean, many people might find models that can work with climate data, which they are all openly available, quite useful for their problem. In the same way with infrastructure models, infrastructure data. So I think that's kind of, for me, that's one of the keys in terms of making information open and accessible would be quite an interesting future challenge.
Fantastic, thank you. So I'm going to draw this session to a close. I'd like to take the opportunity to thank everybody who's come along to listen, asked a question. I'd particularly like to thank Raghav and Anna for talking so much and giving us so much insight over the last 50 minutes or so. We've heard around how our risks to infrastructure are growing and changing in the years ahead as both our infrastructure evolves and as the climate changes. We've thought about some of the things that we can do to tackle those, both from a kind of an engineering perspective, whether that's through grey or nature-based interventions, and some of the methods that are allowing us to, or starting to emerge, that allow us to be a bit more flexible in developing responses to a changing climate and some of those uncertainties. I think that if I was going to pick something that I think is really crucial to help us all move forward, it is to set out, what do we mean? What is the kind of our vision for a climate resilient infrastructure? And what does that actually mean? And how do we get there? And how do we measure that? We didn't get a chance to really unpack how we monitor progress in terms of delivering resilience. But for me, I see that as a huge challenge, and something that does require the government and the Environment Agency and water companies and other organisations involved in this to engage in. So a final thank you to everybody, and to also encourage everybody on the call to stay up to date with the latest events and news from the Awardee Excellence community by logging into the Awardee area, the Academy website, and signing up to the newsletter there. A attendance feedback form will be circulated after the event, so please do fill that in and put forward other suggestions for events you'd like to feature in the Academy CAFÉ event series. And on that note, I'll say thank you all. Enjoy the rest of your day, and I hope it is infrastructure disruption free. Take care.
Thank you. Bye.